Okay, I guess let's just jump right in. It's 2:15.
Mine's standard.
Am I there? Cool. So this is Drupal performance tuning, a jump start. It should really say it's Drupal 7 performance tuning. I haven't really done enough with Drupal 8 to be able to tell you much about what that's going to be like. If there's time at the end, there's a few slides that detail just a few of the things that we can expect with Drupal 8. But for the moment, we're mostly talking about some of the challenges that we have with getting performant pages in Drupal 7. This is, well, I am, first of all, I am Les Lim. I'm a developer at 107 Interactive, which is a small little boutique web shop in Minneapolis. I am from Minneapolis. It's a great place to live. If any of you guys are planning on looking for a move, then the Twin Cities community is one of the greatest Drupal communities that you could possibly ask for, and we're always welcoming to new people. And if you're not moving and just considering a visit, you should totally stop by. We have meetups like every week. Literally like every week there's something going on with the Twin Cities Drupal community. Today, in the next hour, we're going to talk about a few things. We're going to focus pretty hard on various layers of caching within Drupal, because caching is one of the easier wins that you can get with performance tuning. Beyond caching, we're going to talk about ways that you are going to be able to measure the performance of individual page components. So how long it takes for your entire site to render, how long it might take for individual blocks on the page to render, or individual panel panes if you're oriented that way. And also talk about some best practices, processes for site builders, developers. This is sort of going to be oriented somewhere in between beginner and intermediate. Hopefully you'll be able to get stuff out of this even if you've never installed a Drupal site before. We're going to talk about some contributed modules that are out there that don't require you to write any code. But there are going to be considerations even for developers who are pretty familiar with how Drupal works. We're not going to talk about some things like varnish, like CDNs, or other kinds of advanced external caches. These are wonderful things. They're just outside of the scope of what we have to talk about, and I'd love to be able to talk about that maybe afterwards if you guys have questions about that. But we're going to leave that for another day. Also, some of the more advanced profiling stuff, XHProf, Xdebug, some of the paid-for services like New Relic. We're not going to go over that as well. We're going to go over just tools that are available to you and easy to install and use on your own without a great deal of fuss. So first of all, caching in Drupal, and we're going to focus mostly on caching of renderables in Drupal. So things like pages, things like blocks, views, and panels. We're not going to talk so much about the internals of caching or how that works, or caching on the field level, mostly on things that are rendered or ready to be rendered and are stored in the cache layer so that they can be retrieved quickly. So first of all, the page cache. Just a quick overview of the page cache. It takes the entire HTML output of your request from the head to the body, and it stores it in the database, or it stores it whatever store that you have set up for your cache. It's keyed exclusively by the URL, and by keyed, I'm saying that the URL is what's used to determine whether or not to retrieve an element from the page cache. It doesn't take into account anything else. It doesn't take into account your cookies that you might have on the site. It doesn't take into account any of the headers that were used to request the page. It only cares about what is the URL I'm hitting. And it only works for anonymous users. Anybody who is logged in, the page cache is going to be bypassed. And that's because Drupal, at core, doesn't understand how it might need to vary a page response for other user requests. So it's unable to make judgments about whether or not it can cache an entire page response. It feels like it can make those judgments for the anonymous user, because anonymous users are assumed to be all sort of equal to each other in what they're going to be retrieving. So the page cache in Drupal core only good if your traffic is really mostly served at anonymous users. The page cache has several additional limitations beyond that. The various times in Drupal, the page cache can be completely ignored or bypassed by modules. If you have a CAPTCHA on a form, or if you have the honeypot module, which is a great spam catching module, both of these modules will actually prevent the page from being stored in the page cache entirely, because it has to be able to seed the form that's on the page with something that is particular to that particular instance of the form. So it's unable to use some of its caching mechanisms that way. But it means that not just the form can't be cached, but the entire page doesn't get cached. Similarly, anything that creates a user session, so an Uber cart or a commerce cart, something that an anonymous user might be able to come in it and change what the page might be displaying based on a session variable, that will cause the page cache to be skipped entirely as well. Which makes sense because I wouldn't want somebody else's Amazon cart to be showing up in my user session. Additionally, the PHP input filter, if there's any evaluated PHP code on this page, most likely the page cache is not going to be used at all for those things because that's considered dynamic content. And I think the PHP module just turns off page caching entirely whenever there's an evaluated piece. Also, things like URL parameters, and this relates to the fact that the page cache is keyed by URL. So when you have, for example, a Google request that adds a UTM source variable or a parameter at the end of your URL, or anything that adds a little bit of extra information to the end of your query, that's a new URL. That's a unique URL according to Drupal and according to the web, and that will drop a new entry in the page cache based on that. So it doesn't matter necessarily if you're hitting the front page if you have different UTM source variables in there that have been put in by Twitter or by Facebook or whatever mechanism that you have to bring people to your site. Those are things that will cause page caching to break. In addition, the Drupal 7 page cache is all or nothing. When Drupal tries to decide whether or not it can remove pages from the cache because those pages may have been updated, it has no idea which individual pages in the cache have become stale. It has to close everything to make sure. And this makes a little bit of sense if you know a little bit about how Drupal composes a site with nodes. You might have a news content type, and that news page, if you were to update the body of it, obviously that news page itself is going to be something that needs to be cleared. But you might be using that news content type in several different ways. It might be collected into a view on your front page, displaying snippets or teasers. It might be displaying in a sidebar on every blog post. Drupal has no idea where an individual node might be being used, and so to cover itself, it just clears everything out of the cache. So you will experience spikes anytime that the page cache is cleared, or the cache is cleared at all, because there is now nothing in the cache anymore. Every page is being rendered from scratch. And a page rendered from scratch in Drupal can mean several hundred different calls to the database in order to compile the contents of that page. So the entire cache getting cleared at once can lead to a stampede of requests on your database server. That's something you would like to avoid as much as possible. In addition to being all or nothing, the cache invalidates or clears itself really, really often. A couple of the times when the page cache will be cleared, anytime you save a node, you're adding a new node or you're updating a node, that will end up clearing the page cache and the block cache. Cron runs will have the same effect. The entire page cache and block cache will be destroyed and rebuilt from scratch. Anytime you enable a module or disable or update a module, that will also cause the same thing to happen. So if you've built your site in such a way that you've got nodes being added on a consistent basis, like every minute or so, then you're going to have a lot of cache misses. There is a setting in Drupal called the minimum cache lifetime, which can help prevent this to some degree. So the minimum cache lifetime is a setting on the performance page in Drupal, and it has settings like 1 minute, 5 minutes, 15 minutes, all the way up to, I believe, 1 day. And when there is a non-zero minimum cache lifetime, that tells Drupal that you are not allowed to flush the page cache or flush the block cache until at least minimum cache lifetime has passed since the last time the entire thing has been flushed. So it still flushes the entire cache when it does. But say, for instance, your minimum cache lifetime is 1 hour. You will experience nothing in your site updating from cache until at least 1 hour has passed. And at that point, the entire page cache flushes, and that process starts over again. There are a few modules that you can use to help get around some of these limitations. Probably one of the best ones that's available is something called expire module. And this takes a little bit of configuration, but it allows you to clear pages selectively from the cache so that it's no longer an all or nothing scenario. It tends to work best with a minimum cache lifetime set, so that you can ensure that your page cache is available for up to, say, an hour, but that within that period of time, Expire is able to selectively remove pages that it knows about without clearing the entire cache. An example is that you can configure your, with the Expire module, you can configure it so that when you update a news item, that it clears the front page, it clears the actual node of the news item itself, and some custom pages that you define. So here we've added some custom URLs, such as clear out anything that starts with blog, and also clear out the users, the author of the news node's user page. So whenever an action happens with a node of the news content type, it will immediately invalidate from the page cache these selected ones while leaving other things in the page cache. There's additionally an alternative database cache module, which is a variation on the minimum cache lifetime concept that applies per item in the cache rather than for the entire page cache. So that rather than having an hour where the entire page cache sort of stays in memory before it's flushed, each individual page in the cache has that 60-minute minimum cache lifetime and can be cleared out individually rather than all at once. The benefits of this is that it kind of helps smooth out your resource use so that instead of having those spikes in your database where your entire page cache is wiped out and all of those requests are hitting the database to compile their pages, only the pages that are available or ready to be expired, that are past their individual cache lifetimes, are taken out, so that only parts of your page cache is invalidated at any particular cache clear. This also is perfectly compatible with the Expire module, so that even if you have a minimum cache lifetime set on an individual page, your Expire module settings can still clear that out before that minimum cache lifetime is hit. There's also Boost module. Boost is actually a total replacement for Drupal's internal page caching system. It will drop flat HTML files for pages to use so that there isn't even a bootstrap of Drupal. It allows you to have a request go directly to the HTML file so that only your server is invoked when returning a response. That saves a lot of time and resources because not bootstrapping Drupal makes for extremely fast page responses. This also is actually something that works pretty well with the Expire module. Boost has integration with Expire so that when Expire fires its events, Boost listens in and is able to invalidate the cached HTML pages that it saved as well. We're not going to talk about this in depth, but Varnish is another very popular way to get around this problem. So Varnish sits in front of your entire server stack on your server hardware, so that it can save contents of your page to memory instead of to the database. So the upshot of that is that it doesn't even necessarily have to invoke your Apache or Nginx. It certainly doesn't have to invoke Drupal. If it finds that the page content is in memory for this particular URL, then it can serve it directly from Varnish at the layer that's closest to the user, rather than having to go and bootstrap some of the more expensive stuff on the page. You can also configure Varnish in such a way that it doesn't just rely on the URL, but it can rely on certain things that are in the header, or it can look at cookies that are being sent as well and determine whether or not to vary the response based on those things. Again, it works really well with the Expire module. It can listen into the Expire module's events and clear out selectively just the way that Boost or other modules can as well. And beyond that, there is something called the auth cache module in Drupal, which makes some level of page caching available even to authenticated users. This is a little more challenging because this will often require you to determine how to render things on the page that are more dynamic, things that are related to the particular user role that's going to be viewing the page or the particular user that's viewing the page. You may have to have some developer experience to help you figure out how to replace those dynamic page elements with auth cache, but this also helps if you've got the majority or some major portion of your traffic coming from authenticated users, because again, you can't rely on the page cache at all when you are serving to authenticated users. So beyond the page cache, it's important to be able to ensure that the rendering of a page from scratch can happen as fast as possible. So the components that make up the page, we've got to make sure, have their own individual caching and are responsive in their own rights. Block cache can help you. So Drupal has its own block cache by which it allows individual blocks on the page to be cached according to various contexts. It stores a block array that's ready to be compiled. It works for logged-in users as well as anonymous users. And it can even help lower times for anonymous users because even when the page cache is totally cold, the block cache may not be cold. So there might be cached blocks that help reduce the amount of time it takes to render the page as a whole. So each individual block has a cache setting that determines when you should be able to cache different variants of the block. And so when I'm talking about variants of the block, I'm meaning that there are times in which the block will display different content depending on who is viewing the page or who is viewing the block or which page the block is being viewed on. And you are able to configure on a per block basis what level to vary that content. So the options that are available to you in Drupal include caching once for all context, so that block will appear the same to everyone on every page. It can be done per page, so that the block is able to show different contents depending on the URL that you are visiting, but it will show the same content for everyone who visits that URL. It can vary it per role, which is that the block will show the same for every one of a particular combination of Drupal user roles, but it won't vary, it won't make a difference what page you're on. And it can also do it for combinations of those things. So per role per page, per user per page, these are also options that are available by default as cache strategies for individual blocks in Drupal. And this is a screenshot taken from the views interface for blocks. When you create blocks within views, then part of the user interface allows you to set what level that block can be cached at. So some examples of different cache settings that you might want to use would be a block that contains a mega menu. It's going to be the same for everyone on every page. You would want the cache setting for that to be global. It shouldn't vary depending on who's looking at it or what page you're on. A different possibility is that I want to show the current logged-in user's most popular blog posts. So something that could show in a sidebar or a dashboard that's intended just for that user. You would want that cache setting to vary per user. It shouldn't matter what page you're viewing it on, but it should show the same stuff for me anytime I view it compared to anytime Jim views it when he's logged in. If I've got a block that shows moderation options for the current node, where different roles are able to see different options, then you're going to have to use one of those combination cache settings, per role per page in this case. Per role because different roles see different options, and per page because the links to the administrative options for that node are going to change depending on what node you're viewing. So the unfortunate thing about those cache strategies is that they're baked into Drupal core and they're hard-coded. There is no way to extend Drupal's base block cache settings to add new cache settings to the Drupal system. So for example, if you have a block that is showing the currently viewed node author's profile with a picture and a bio, you probably want to be able to vary that block according to the author of the node. Drupal doesn't allow you to do that. There's no strategy baked into Drupal on this list, which is the current node's author. So that block is still cacheable, but you will have to write custom code to be able to cache it at the level that you are intending to do it. Per page would be close in this regard, because at least it would be per node, but it wouldn't be the most appropriate, because you still would want this block to show on any node that this particular user has written. And this per page cache strategy wouldn't be able to catch you. Another example would be a block that contains a view with a pager. We'd love to be able to vary the contents of that block according to the page you're on, but that's not available as one of the block cache settings. So in that instance, you can't cache it using regular block cache settings. You have to set it at do not cache so that that page variable can be picked up. It's actually possible that you might be able to use per page as well, because the page is something that comes in as part of the URL. But that might get dicey depending on how you're using the pager. The block cache is also never invoked for user ID number 1. User ID 1 always renders the blocks from scratch, which is another good reason why you should never be logged in as user 1 when you're actually doing testing. You should always have some other test user or test for the roles that you are fulfilling a user story for. Additionally, block caching just isn't available at all. It's not an option in the interface if you are using certain node access modules. Anything that happens to use the table in the database called node access will prevent block caching from being available to you, which is unfortunate. This is something that just recently in Drupal core they allowed you to turn off as a feature, so that you can drop this line in settings.php and make sure that even if you are using node access modules, you're still able to use the block cache. And whether or not that's appropriate depends on how you're using the node access modules. So that's really a per case basis. Besides those things, the block cache is also subject to frequent cache invalidation, just like the page cache is. When you're submitting the node form of the block edit form, that will end up clearing the entire block cache. Cron runs will do it. Modules that are being enabled, disabled will also cause the entire block cache to be completely truncated and then rebuilt from scratch. Again, the minimum cache lifetime can help cover you here. But one unfortunate thing, I haven't found anything like the expire module that's equivalent for blocks. Blocks are really seem to be an all or nothing thing. If I'm wrong on that, I'd love to hear about it. But there's nothing that I found so far. Some things that will help you when you're working with the block level cache. There's a module called block cache alter. That actually provides the user interface that allows you to, on a per block basis, change the cache level or the cache strategy that's being used for that block, because there is no interface for that in Drupal core. The block cache alter module is really just a wrapper around the function hook block info alter. So if you would rather put it in a module, that's probably a slightly better way of doing it than block cache alter. It saves you a database call to get the settings for block cache alter. And the code for block info alter is not particularly hard to look at. The examples are pretty straightforward. If you happen to be working with blocks that are created by views, so they're block displays, then you can also get that interface directly within Views module. It's easy to miss. It's in the advanced settings for your view display, and it's stuck at the bottom. So you see that that do not cache setting. That's a link that brings up that interface that we were looking at before. You might also notice there's also there's separately a caching option on that display. That's for views caching, which we're about to talk about now. So in addition to the block cache. Both views and panels have their own mechanisms for caching the components that they exposed for a page. The output for those things is stored as HTML, and it's retrieved and automatically keyed according to some very useful things in Drupal that you would want to have cached by, such as the language, the user roles that are going to be accessing the particular view or panel, the domain as well. It can also vary that cached item according to the page or the arguments or the contextual filters that are being used with the view. That tends to only work when using SQL as the backend because it's related directly to the query. But these are very useful as sort of default ways to vary the response coming from a view. So the cache options that are available for views and for panels panes come with their own limitations. Both of them out of the box only come with time-based invalidation. So similar to what the page cache comes out with, or the block cache, you can tell it how long to keep something in cache, but you can't give it more granular rules for when it should expire things from each individual cache. So you might, for instance, be able to say, I want this view to be cached for up to an hour, but if you were to change any of the results of that view, any of the contents of that view, within that hour, you would not be able to get updated responses in your view until that entire hour has passed. The view does not clear itself out intelligently when the contents of the view should change. There are some tools in the contrib space that will help you get past that. Both views and panels have modules that will provide alternate caching mechanisms to views and to panels. So views content cache, panels content cache allow you to create rules that are similar to what expire module uses, such that you can tell your view of blog posts that it needs to invalidate itself whenever a blog post is added or updated or deleted, so that you can make sure that you instantly are getting new up-to-date cache items whenever you are updating your blog. Caching in views isn't turned on by default, and some people think that that's a bug. So they've created a module called Views Cache Bully, which enforces caching to be on by default for all views. I'm not a big fan of this personally. I think that caching is something that you should think about and do intentionally. But this is certainly one way to go about it as well. Views like Pager doesn't really have anything to do with cache. It really is just something that I wanted to mention because this has killed me before on sites. The pager in views, the default pager options, can be extremely slow in SQL when you're using what's called the InnoDB engine in MySQL. And part of the reason is that it does a really poor job of counting the number of items that are in a query. It takes a long time to do, and the pager needs to know how many items are in a particular query because it needs to know how to render that last link that's in the pager. That last link will tell you that you're going to be skipping to page 688, and it needs to know how many things are in that view in order to know that the last page is 688. Turns out that in various circumstances, this query can take, I've seen it take upwards of 3 to 5 seconds before, which is killer if that's, for example, the front page of your site, which is very common. Light Pager gets past that by not bothering to count the next page. It just shows you the next page. It gives you a link for the next page, and it doesn't have to know that what the total number of items are in the view in order to give you just the next page's worth of items. So highly recommended if you are working at all with large quantities of things to be shown in views. So caching is helpful. It can only get you so far. You also should have some idea of what it is on your page that is taking long to actually render. So you can optimize view as much as you want. If that view was only taking about 30 milliseconds to compile in the first place, then you're mostly wasting your time. It behooves you to know what it is that's causing the most trouble on your page when you are rendering it. To that extent, there are various tools that you can use in Drupal. At the level of the page itself, then devel module has a handy tool to give you the amount of time it took to render that page, to construct that page from scratch. In the devel options, it's a page timer. It can also show you the amount of memory it took to compile the page, and that just displays in a footer at the bottom of your page. That can be handy. It's sort of redundant with, say, using the network tab on Firebug or in Chrome Developer Tools, which can tell you some of the same stuff. In some ways, yeah, I like to have both depending on what I'm looking at it for. It's a basic tool. There's also a module that I only have in Sandbox, but there is a module for profiling the time it takes to render individual blocks, or panels, panes for that matter. I have a link there. I'll put the slides in the session link for this particular session here so that you can get to it. In order to get the code, you'll have to do a git clone of it because it's a sandbox still. But when it's available, it can show you the number of milliseconds that it took to render any block on the page, any pane on the page. For example, we can see here that the block that's coming from the views module that's labeled slides block, that's 203 milliseconds. That's a candidate for caching, potentially, if we can get that down to something more like 30 or 40 milliseconds. That's an easy win for the site. And again, when we're optimizing individual components, we're trying to shave hundreds of milliseconds off of individual things that are cumulative over time. So every little bit can help when you're optimizing. So it requires the devel module to be able to print out the results of the timing to the top of the page. It also requires a core patch, which, sorry, the core patch is pretty tiny. All it does is it uses Drupal's built-in timing functions to start a timer when we start rendering a block and to stop the timer when we're done rendering the block. There's really no really reliable way to get timing information out of Drupal for blocks without being able to insert your timing functions directly in the code execution. There aren't really hooks for I'm starting to render the block and I'm done rendering the block. But I would argue that when you're developing, it's okay to put timing functions into core, into contributed modules when you need to gather data about what those things are doing. You obviously wouldn't want to commit this to your production code base, but I don't think that you should be worried about killing kittens when it's for the purpose of development and gathering good information about what it is that your code is doing. So we'll often have this just as a patch that lives next to Drupal core, and if I need to have this information, I'll apply the patch, and when I'm done with it, we'll just we wipe it away. But the ability to just get timing information in various parts of Drupal core is extremely powerful, and it's something that that you shouldn't shy away from. So when you're using those timing functions, it's helpful to have something like devel module and its DPM functions so that you can actually see what the results of the time is printed at the top of the page. If you prefer not to see them directly on the page, then you can store them with a module called object log. That's a module that I've written to take the results of what might have otherwise gone to directly to the page in a DPM call and print them out to a table so that you can review them later on in your administrative interface, so that it prevents you from polluting the page output with your DPM calls. It's also generally useful for things that are for when you want to get information on variables that are outside the context of a normal page request, such as a cron run or like a server-to-server request. Something that so it's helpful. I recommend it. I also wrote it, so yay me. Xdebug is a program that it's software that's run as part of PHP. When enabled, it can give you profiling information for all of the functions that are run in the course of the particular page request, how long it took each function to run, and how many times it was executed. That can be a whole bunch of information, but going through that information can be very helpful determining where potential bottlenecks are. Xdebug also has something called traces, where you can sort of get a mini profile of just a section of your code rather than the entire request. So potentially very helpful for profiling. There's also XHProf, which I don't have very much experience with personally. It's something that's claimed to be able to be run in a production environment because it doesn't run on every particular page request. It takes a sample of requests. It gathers a lot of the same profiling information that Xdebug has. It's considered safe to run in production. I don't have very many opinions about that. It's something written by Facebook. A lot of people swear by it. I can't tell you much about it. For SQL queries, Devel module has tools again for this. There is the query log, and that will take literally every query that was used to render the page, shows you the function that contained that query, and will display it in one big vomit of output below your page. It is useful in the absence of other better tools, and it does give you information about timing, but it's not something that I would recommend keeping on for the course of development. But it can be useful for instance, the numbers that are being shown in that second column, or the number of times that a function has been called in the course of this particular page request. If that number is particularly high, then you might have some indication that that's a candidate for caching. That's variable according to the kinds of things you're doing within that function. Besides the query log, MySQL has something called the slow query log. I think most SQL-based engines have something similar to the slow query log. The slow query log will allow you to set a threshold above which that queries can be saved, so that you can figure out what are the queries that are really that are taking down your site. It can be logged to a file, which it is by default. It can also be logged to a table in the MySQL database within MySQL, so that if you prefer looking at queries in your whatever SQL environment in PHP-MyAdmin or in SQL Pro or whatever, that's possible for you. It's not something that I necessarily enjoy. There are reasons why it can be nice to see that in a file. The table, for example, doesn't show milliseconds for queries that are executed. It shows seconds, which is not that useful in the context of database queries. But it can be helpful just to be able to view it graphically in a table and introspect it that way. Enabling the slow query log is a matter of adding some lines to your configuration file for MySQL. So turning it on, setting the threshold above which you would consider a query to be taking a long time. So that would be set at 200 milliseconds right there. And a minimum examined row limit would be how many rows the query had to look at in the database in order to qualify for a long query. And the reason why you might want that set at something above 1 would be, for example, you might not want to log inserts that you know are going to take longer than 200 milliseconds. Inserts would only generally affect a single row. So you might only want to be worried about select statements over large results. Over 5 generally seems to be a threshold that would be fine. And then if you wanted the log output to go to a MySQL table, you can set it here as table. When you're examining slow queries, there are a few things that you can look for, and this is where it starts to get a little more developer-y. It's hard to know what to look for without having some experience and just practice in looking at SQL queries. Generally, large data sets, like lots of rows being examined, is an issue that will complicate the length of time it takes to execute the query. Certain clauses can be problems. So where clauses, group bys, order bys, wherever the thing that you're filtering by or grouping by is not an indexed column, that can cause MySQL to have to try to figure out on the fly which rows it should be examining and how to assemble those rows. One that often trips people up: order by clauses. Even when they're indexed, if they are on columns from joined tables that aren't the base table, then that's not something that MySQL can use indexes for. So, for example, then if you've got a view of nodes in your database and you are ordering them by the value of a field that you've added in Field API, that value from Field API is in a totally different table from Node. And ordering by that column can take a long time if there are a lot of rows in the result set, or a lot of rows to be examined in the result set. It can be a lot easier to just figure out a way to not have to order by anything at all, or to order by something that is on the base table or the leftmost table of your query. And so, yeah, it's confusing, and it definitely takes a lot of reading and practice to get into it. These are just a few of the things that will commonly cause queries to start bogging down. Beyond that, you can use what's called explain statements, at least in MySQL, in order to get even more detailed information about why the execution of a particular query might be going slowly. So you would be able to go to your slow query log, pick out a query that took a long time because it would display the whole query within the log, paste it into your MySQL interpreter with explain behind it, and instead of running that query, it will figure out how it would run the query and display you information about that. It's out of the scope of this particular presentation to explain how that works or what to interpret out of that, but that is probably the best source of information about why a query is running slowly, if you know how to interpret what the output of that is. So some general recommendations, given all of that. You should disable the query cache during development. The query cache is something that MySQL has available to it, and the way it works is for select statements, it will take the literal text of the select statement, take the result of that select statement, and put it into a special in-memory cache for itself, so that the next time that exact same select statement is run, it can retrieve the results directly from its own internal query cache. This is generally so it's an iffy idea. I actually don't particularly like this even in production, but certainly in development, what this can lead to are false positives for fast queries. So a query that might have taken 5 seconds to run the first time, the next time you run it, you think, what the heck happened? The next time you refresh the page, it will be nearly instantaneous, and that's because it's returning it from the query cache. You didn't fix that slow query. It's just that the query cache fooled you into thinking that the problem was fixed. So in order to make sure that you're getting the most information out of the query or out of the profiling during development as possible, it's probably a good idea to turn that off. So again, in your my.cnf file, setting query cache type and size to 0 will cause that not to work. Another thing too, when you are developing, you should enter all the content that's going to be on the site, if at all possible, into the site. Things happen in MySQL differently when we're on the level of many, many hundreds of thousands of records compared to 10 records. At some threshold that's different in every occasion, large numbers of rows being examined will cause MySQL to have to throw up its hands in the air and try to figure things out from scratch. You won't know when you're going to be hitting that threshold, so it's always a good idea to sort of assume for the content that you're actually going to have rather than just some small subset of it. If you are not able to migrate in all your content or enter in all your content at the beginning of development, and that's very often not likely, then do your best you can to fake it. So use devel_generate module to create entity types, stub entity types, and create them in the numbers that you are expecting to have in your site. So that, first of all, it's just helpful to be able to have examples of nodes that are available during development so that you have something to look at. But besides that, it will simulate the relative same plan that SQL will use when you've got your real content as well. The plan that SQL executes when it determines how to run a query. Don't test as user one. This is something that I catch people doing all the time. I catch myself doing it. That's how bad it is. You should really just stop doing it. It's fine, I think, to assign develop permissions to other roles in development, as long as you're sure not to be able to push that to production. If you need devel to get profiling information for just a regular authenticated user that isn't an admin, you should get in the habit of either using Masquerade or just having a different browser that's logged in as the user you were testing as to do your actual tests to make sure that you're actually creating the functionality that you expect you're using. User one is never going to replicate what the actual user experience is like. Finally, there are ways to incorporate the profiling into your workflow. This depends on your existing workflow, but you can certainly make this something that happens during QA, so that once your test suite runs, whether that's PHP unit test suite or BHAT, or it's an intern sitting in the back of your office, those tests aren't necessarily going to know if something is happening slowly. They'll be able to accept that something correct happens, but not that it happened quickly. You might make it part of the process to review the slow query logs at the end of a QA run to see what happened during the course of that run. If anything new got entered into the slow query logs, so you know the things that you have to look at. You could leave profiling on during development. This is actually something I do a lot when I'm constructing sort of how a page is going to behave. I will have my block profiling module sort of just on all the time, and I'm pretty good about just sort of blocking out the output that's out there. But just being aware of it and being aware of generally like the amount of time that things are taking will always remind me that during development I need to be looking at ways to make things faster when they're slow. There are you could set up commit gates so that you do not allow things to be committed if the performance of the particular components on those things is above a certain threshold. There are certainly ways to do it. And they don't have to be automated. They can just be part of your own consideration of how you develop as well. But it should be a consideration. So Drupal 8, there are a few quick things that Drupal 8 is gonna have out of the box, which is going to solve some of the problems that we have in Drupal 7. One really great thing is this idea called cache tags. And so the idea of this is that entries in the cache can be tagged with information about what nodes, what contexts were used in the course of creating that entry. And the benefit of that is that instead of Drupal not having any information about what's in the page cache and having to clear out the entire thing, it suddenly has a wealth of information about what was used to construct its pages. And so it knows that if you have updated taxonomy term 1, it can find the cache entries that are tagged taxonomy term 1 and selectively invalidate just those entries, leaving the other ones in place. There's a cache context API, so that whereas previously you weren't able to describe to Drupal additional block caching strategies, you can now create those in code and tell Drupal about them so that they're available in interfaces like this. So for example, here's the block configuration display in Drupal 8. And at the bottom of it, you see this area called Vary by Context. And it's added additional options there that are not necessarily available in Drupal core. Contributed modules have gone in and added things like, I want to vary by time zone, or I want to vary according to the access grants that have been made available from the content access module, for example. So that system is now something that's extendable. Another really cool thing that I've only just started to look into a little bit, something called Smart Cache. Wim Leers has been like flogging himself trying to get this into core. It's a replacement for the page cache that knows about components that are used to create the page and can individually store metadata about the cacheability of those components, so that when it sees a page that has some dynamic elements in it, it can cache just the parts of it that are static, the things that are going to be the same for all users, and then figure out how to just render the things that are dynamic for your authenticated users, depending on whatever contexts that need to be available for that page in order to fill in the blanks. So it's a cache that can work for everybody. If this at all lives up to the promise that it's shown right now, then this is going to be a huge win for cacheability and for performance in Drupal 8. There's a bunch more, but not in my presentation. So that's what I got. Thanks for coming. If there's questions, we've got like 10 more minutes before we're supposed to get out of here. Yeah.
How many of these things can I use together? Can I boost and page cache and block cache and?
So you can boost and expire together. Expire you can use with just about anything. Expire is great. You can block cache with any page caching that you want. So block cache will be useful regardless of how you're storing individual page requests, because it will make cold cache requests for pages faster as well. The same concept applies for views or panels caches and block caches as well. All of those things will make rendering individual pages faster from a cold cache. You will get maybe into problems when you're doing things like trying to combine block caching and views caching for things that are like a views block.
Okay.
You will end up caching that thing twice in that regard. So you will, with a views block, potentially cache things in views. So views will then retrieve something from cache to render the block. Block system will then cache the outputs of that block as well. In the end, block cache is going to win. Block cache is going to return the thing that was cached. Views isn't going to be invoked at all in that case. But they have different expirations.
Would it be faster if I did have both of those things on?
So this is an interesting point. Something that I actually didn't find out. I didn't think about until I started profiling these blocks. Block caching is nearly instantaneous. Like it's down to under a millisecond to retrieve something from the block cache. The views cache, even for something that is perfectly cached in views, if you're just using views internal caching, that thing still takes anywhere from 30 to 60 milliseconds just to retrieve the view object from the code, to execute all the things that views needs to do just to get that object off and running, and retrieve a cache response. So even using just views cache, you're still executing a pretty good chunk of code. You might not think that like 30 or 60 milliseconds is a lot, but if you've got 5 different things that are cached on the page, that starts to add up. So actually, if at all possible, if you can cache things in a layer outside of views, then that can be a good idea. So something that I'll often do is I will create programmatically, I'll create blocks or I'll create panes that just display the output of views, but I will write my own cache logic on top of it so that I can use my own block caching without having to worry about the views cache level at all, if that makes any sense.
Sure, yeah.
So yeah, there's a lot of different combinations that you can make.
Is there anything that's detrimental to the production server, like say leaving devel on?
So yeah, like devel, depending on especially the things that you have set up to use devel with. So like the page timer or the query, especially like the query log, because the query log drops a flat file to the temp directory in order to store that information. You would definitely not want to have that on in production. I don't know exactly why you would want devel on in production anyway.
Accidentally.
But accidentally, sure. So I mean, I've seen it. I've done it accidentally. I haven't noticed it bring anything to a halt. I mean, there is some code weight within devel itself. But if you are not actually, if you haven't left accidentally, your DPM calls in code, and you haven't accidentally left on like query logging and stuff, I don't think it's a big deal.
Yeah.
Mm.
Slows you down a little compared to all these improvements you made.
I think it's negligible, but I haven't done any profiling. That would be a good thing to profile.
Okay. And the query log is good to know too.
Yeah. Yeah.
Have you looked at stuff like Redis? Is that like MySQL or just an object cache?
Yeah, so definitely use memcached. I haven't used Redis at all yet. It's intriguing. I just haven't had a chance to. We've used memcached in a bunch of different projects, and that's been great. So yeah, we've used that as a drop-in replacement for like pretty much every cache table except for cache page. And we usually use something else for cache page. But that's huge. Yeah, found that can get a little dicey in Drupal 7 with lots of really high traffic sites. There are some race conditions that come into play when you start using really fast external caches. Those are things that the community has sort of been able to get past. There's a module called cache consistent that Drupal.org uses that prevents a really nasty race condition for when you're using it in an external in-memory cache. And these things are not well documented, unfortunately. I think there's things that people know about and like talk about amongst like really high traffic sites that are using these things, but yeah, I wish there were more communication about sort of these tools that are out there, especially because Drupal.org uses this thing, and it's been there for like a year, and virtually no people really know about it. But not really part of the scope of what this was. You should be able to have perfectly good performant Drupal pages without having to resort to external options. Yeah.
How do page cache and block cache work together? If a page gets cached, then the block cache not be called, or they get separate?
So if there's a warm page in the cache, the block cache never gets called. The page response just gets returned, and none of the stuff to render the page ever gets called. And that's the whole point of it, so we can avoid the expensive rendering. If it's a cold page cache, that URL is not in the page cache, but some of the blocks that are going to be used to create that page are warm in the cache, and the context for that cache are correct, for those blocks are correct, then it will retrieve those blocks from cache and use those instead and prevent the rendering of those things. So so page cache makes block cache irrelevant, but page cache clears itself and is so unreliable in terms of when it's going to be warm that block cache is still necessary. It's also still just necessary because your logged in responses will benefit from block cache. Cool. It's 3:13, so I don't know. We've got talking stuff.